kind of makes it more a homogeneous mixture, conking and refining together. So now let's talk about tempering, and we kind of brushed on this a little bit, Shen kind of brushed on this a little bit earlier. So cocoa butter is like 96 to 98% triacylglycerols. Those triacylglycerols are sus. They're the saturated, unsaturated, saturated configuration that Shen kind of talked about earlier, specifically 2-oleopalmitostearin. So that means the second fatty acid unit is an oleic acid, the first is palmitic, and the last is stearic. These are polymorphic molecules. Who knows what polymorphic means?
We haven't talked yet. We'll talk later.
So polymorphic means it can take many forms.
Yeah.
In cocoa butter, specifically, there are 6 different configurations. Well, 5, but really 6. Betas 1 through 6. Beta prime 3 and 4, as you can see, is kind of looped in together. But each one of these polymorphs has a different melting range. And when chocolate is what's called in temper, that means you have the majority beta 6 and 5. 5 and then 6. What's super interesting about the polymorphs, they all want to be beta 6. So when they grow up and they age so nicely, they will be beta 6, whether you want them to be or not. And that's where bloom happens. So as those molecules, and I'll show you a really nice picture here in a second, they kind of interlock. Whether they are disorganized and not interlocked, when the chocolate hardens, they will get to the point where they're interlocked, whether you intend it to or not. When they are not interlocked intentionally, fatty acid, the bloom happens. And so the fatty acids kind of come, they migrate and they come to the surface and it looks ugly. I'll also show you some pictures of that as well. But if you get most of them organized in a beta 5 form, it's more like they're just kind of falling into place rather than like actually traveling and migrating. And so the bloom does not occur. They still migrate to beta 6, but a bloom and the unsavory, it's not unsavory, it's unsightly. It does not look pretty. It also does not act the way we want it to in terms of chefs or chocolatiers. That doesn't happen if you organize most of the crystals into beta 5. So how do we do that? First, we need to heat the chocolate to 50 C. That gives us a blank slate. All crystals are destroyed. And then we kind of control the cooling to 34 C. Between 34 C and 29 C is where we have beta prime and beta, so that would be 3, 4, and 5 crystals formed. And then we give it this tiny little bump, 29 C to 32 C. It's literally like 10 degrees Fahrenheit. And in terms of controlling that, depending on the batch size, it's quite difficult to do. Once you hit 32 or like 90 degrees Fahrenheit, that has melted all the beta prime crystals, the 3 and 4 away, and you only have the 5 and the 6. So that's when you would mold the chocolate, or place it into whatever container you want to solidify, and then the chocolate will adopt that shape. And that's tempering. So here's some pictures. This is from PubChem. So you have the unsaturated, or the saturated, unsaturated, and so if you the beta prime, they're almost organized, and the beta, they're really set into place. And they didn't differentiate between 5 and 6 here, but there'd be a very small differentiation. But if you look at the alpha, this would be the 1, 2, and 3. It's a mess, and it's not organized at all. So then as these kind of fall into place, anything between any short chain fatty acids, any single fatty acids would move and get kind of pushed out, and that would cause the bloom. So bloom, this would be just poorly tempered, maybe some beta prime, the 4 crystals along with 5 and 6, bloom, this is just a mess of all of them. Someone just heated this chocolate up, poured it into something, and walked away. And so this white is literally due to the crystals traveling to that beta-6 configuration and then pushing the different fatty acids out. And then you have the beautiful tempered, which has a nice sheen if you give it a really smooth mold or surface to like solidify against. It snaps as you bend it and break it, and it's more stable, and so it gives it like a harder texture almost. If I had some bloomed chocolate, it's not difficult to break, and sometimes it actually bends before it breaks. It's actually really weird to watch. So that was kind of a mess. It's been a while since I did that presentation. Any questions? Yeah.
Is there a macronutrient distribution that like favors a certain like beta-5 to beta-6 conversion where you can optimize it, or is it purely temperature control?
That is an awesome question. I don't explicitly, I know the answer is yes. I don't know what the macronutrient distribution is, but I do know, so I gave Shen a batch of chocolate. I have been a chef. I've done a lot of food work. Tempering chocolate is no feat for me. I can do it very easily. I tried 6 different times to temper this batch of chocolate and I couldn't do it. I was at my house and I didn't have my mold, so I just did it on parchment paper. The parchment paper I used was from Aldi. Love Aldi, cheap parchment paper. Every time I peeled the chocolate off, you could see the fat, like grease, on the parchment. So why would absorbent parchment paper or any absorbent material prevent chocolate from becoming tempered based on what I've said? Any ideas?
Because when it's crystallizing, it'd be like an affinity to the paper and draw the fat away from it being like...
Exactly. So even if I organize it and I want, you get like, the little brother like causing hell and wreaking havoc on the bottom and making everything get disorganized. So it was actually very frustrating until I realized that. And then I tried to retemper it again here on the silicone mats and my molds, and I had altered the fatty acid content such that the temperatures that I used and have used didn't temper it properly. It was tempered, but not like super well tempered. And so lower fatty acid content obviously adjusts the tempering curve temperatures, but I don't know explicitly to what extent.
It's more trial and error with each bean, it feels
Mm-hmm.
like.
Yeah, and that's, you talk to any chocolatier that works in single origin chocolate, and that's how it is. That's how it is. And a lot of them have SOX apparatuses or have fatty acid analysis available to them, and so then they can quantify it, and then they can know, like, okay, so I'm working with 55 versus 60, so let's adjust. And I imagine, just shooting from the hip here, you probably need a higher temperature for a lower fatty acid content, because you have less kind of to work with. Yes.
Since you were talking about like the composition of the beans are different based on where they're farmed at, is there like a certain type of like soil composition that farmers look for, like to start a farm, to get like preferred like flavors from the beans?
I'm sure. I couldn't tell you. So
I know if that was like out of the
agriculture, agronomy. I'm not good with that, but I guarantee there is. Just like for coffee or wine, I'm sure different facing slopes get different amounts of sunlight, different amounts of shade, rain, etc. And then the nitrogen in the soil, the fertilizers in the soil, I would bet my life that causes different.
I've heard a weird story about like where they made like cocoa chocolate that would have like coffee tins to it, because they just swapped the field that they were growing both in.
Yeah. The guy I get my beans from, he works with individual farmers. So the Madagascar was organic, the Bolivian was direct trade. So this man reached out to that farmer and worked out the deal and got the beans directly.
Yeah.
So he's gotten beans for generations from this farm, and he will give different tasting notes per year, and they are different per year. Same strain of cacao, same seeds, if you will, but just the way the weather and the way the soil kind of transforms.
So the chocolates we tried, those were both like just sugar and the bean,
Yes.
like, and made the same exact way?
Yes.
Oh, okay, that's
Yeah, wow.
crazy how different.
Yeah, it's wild.
Mhm.
Yeah.
The second one's really good.
Yeah, it's,
First one though, that raspberry, you weren't kidding, without
Yeah.
that
No,
honey, that you get that hint of like a bite of raspberry.
yeah,
there.
it's not an everyday,
Yeah, it's
for me.
interesting.
but that other one, I could eat myself sick, like I have to be careful, for sure. Any other questions? Thank you for being a good audience. I appreciate the participation. I
Very
hate-
good.
Hate lecturing and not getting questions or, feedback, anything like that.